This is video CA12. We're going to cover the third part of chapter 1.6. This is 1.6C, which is complex fractions. And you'll find this on page 88 in the textbook that will be linked below. So let's get started. So first of all, what is a complex fraction? Well, it's a fraction that's complex. A complex fraction is a fraction within a fraction. So that means within your numerator or your denominator, there's going to be another fraction. And the process is very simply stated. What you want to do is create single fractions in your numerator and denominator. And then you can multiply by the reciprocal and simplify. Well, that sounds pretty easy. And this is one topic where experience is your best friend. There are so many different options, and every option calls for a different action. So the more of these problems you work, the more familiar you're going to become with just what can happen. So the hardest part is usually going to be when you are trying to create the single fractions in your numerator and denominator, because this part of it is old stuff. So let's just look at this first sample problem. I'll work several samples because I want you to see the range that's involved in this topic. I have x over y over x. Now, this one, number one, is already done. So what I told you was the hardest part, you're not even having to do that. You have a single fraction in your numerator and in your denominator. So all you're going to have to do is change this to multiplying by the reciprocal, which gives you x squared over y squared. So that's technically what you do, but this was cheating because I skipped the hard part. So let me grab a real example. This is example 6 from page 88, and what we have here is y plus 1 over x over y. So we have fractions within the fractions. So start with your numerator. We need to change this to a single fraction. We're going to combine y plus 1 over x. Now, how do you do that? Well, first, you take any whole number that you have and put it over 1. Y over 1 is fraction form of y. So now I have y over 1 plus 1 over x. How do I convert this to a single fraction? Well, I'm going to have to combine terms. How do you combine fractions? You have to get a common denominator. So what's the common denominator between 1 and x? Just x. So I'm going to rewrite both of these fractions as a fraction over x. This is just like we've been doing. You just have to really think about it. Alright, what did I multiply this old denominator by here to get this new one? Well, I multiplied it times x. Whatever you do to the denominator, you have to do it to the numerator. And instead of putting yx, I'm just going to go ahead and commute those and put xy. Now, what did I do to this denominator to get the new one? Absolutely nothing. So what will I do to the numerator? Absolutely nothing. Now, when I add these, now that my denominator matches, I can put them over the same denominator and have xy plus 1. Okay? Now, your numerator is already a single fraction, so you don't have to do anything to it. So let's come all the way down here. Now I have x plus 1 over x over y. So I'm going to multiply by the reciprocal. I'm going to take the top fraction just like it is. I'm going to multiply by the reciprocal of this. So instead of x over y, I have y over x. Now, when you multiply, you don't really have to distribute when you're doing this, because what's the last step? To simplify. So that would mean you've got to factor out everything that you factored in. And there are times when you're going to want to multiply to see if you can factor it a different way. But for this one, we're just going to multiply straight across the top. So I have y times the xy plus 1 here. They're just in different order because you normally put your single term outside the front of the parentheses. And x times x is x squared. Okay? All right, let's go a little deeper. Okay, let's look at problem number 50 on page 90. This is x over y minus y over x over y plus y over x. So our first step is to change the whole numerator, or both these fractions in the numerator, to one single fraction. You do that by combining, adding and subtracting. What do you need when you get ready to add and subtract fractions? You need a common denominator. All right, now this one's easy. I don't have to factor because it's a single term in each one. What is going to be the common multiple between x and y? xy. So I'm going to rewrite my denominator as xy minus xy. Okay. What did you do from this denominator to get your new one? Well, it's been multiplied by x. So you have to multiply the top by x, and x times x is x squared. What did you do to this denominator to get the new one? Well, this time you multiplied by y. So you have to multiply the top by y, and y times y is y squared. So now this top part, the new fraction, is going to be x squared minus y squared over xy. When you combine the terms, the denominator doesn't change. It's just like, 5/7 plus 1/7 is 6/7. Your denominator doesn't change. Okay, this can be factored because this is a difference of two squares. So I'm going to have x plus y times x minus y. If you're fuzzy on this, look back at the factoring polynomial section, difference of two squares. And the denominator will be xy. Okay, that takes care of the whole top part of my fraction. So this is where I am. Now I have to change the bottom part to one single fraction. It's the same, it's just that this has a plus sign. So our common denominator is once again going to be xy and xy. What did you do to this one to get your new denominator? You multiplied by x, so you got to multiply the top by x. So that gives you x squared. You multiplied this by y to get here, so you got to multiply that by y and get y squared. And you can have x squared plus y squared over xy now, combining the terms. You cannot factor this because it is a sum of two squares, and we don't have a formula for that. We don't have a way to factor that. So our new fraction here is x plus y times x minus y over xy all over x squared plus y squared over xy. Now I just copied that part down here so I can work with it a little bit better. Okay. Now, what's your second step is to multiply by the reciprocals. So my top part is not going to change at all. My sign will change to multiply, and then I'm going to take my denominator and flip it because that's what a reciprocal is. So now I have xy on the top and x squared plus y squared on the bottom. Now, can you cancel things? Well, remember, now that all these are multiplied, this is actually one big multiplication problem here. All of these sets of parentheses are factors, and factors can be canceled. So I can, I say cancel, but what I really mean is divide out to 1, because what is xy over xy? It's 1, and when you multiply by 1, you don't change anything. So whatever remains after you do your dividing out or your canceling out, that's going to be your answer. So our final answer here is going to be the x plus y times x minus y over x squared plus y squared. Okay? And like I said, experience is your best friend in this topic because I cannot possibly work an example of everything you can have. And that's mainly because what you have to do here in step 1, there's an unlimited number of possibilities. So I'd like you to look at problems 42 through 50 on page 90, work those. If you see one that you have trouble with, you can drop the number down in the description and I will put up a video of just that problem, or if you're in my class, you can bring it up to my desk and I'll help you work it. Okay? This is the end of chapter 1, the prerequisites chapter for college algebra. So, the good news is the pace is going to slow up a whole lot now. The bad news is it's going to get a little bit harder, but you're going to be fine. Look, guys, if I can do this, you can do it. I promise you, I am not a math whiz, but I have figured it out, okay? And I will help you figure it out. So, let's get, so this wraps up video 12. I will see you back here video 13, and that will be the first section in chapter 2.